Hello. This time we are going to find the greatest common factor or the GCF of an algebraic expression. Let's give an example. Suppose we have 12 and 20. First, we need to get the prime factors of each expression by using prime factorization. One method of producing the prime factorization of a natural number is to use what is called factor tree. The first step in making a factor tree is to find a pair of factors whose product is the number that we are factoring. We repeat the process with each factor until each branch of the tree ends in a prime. Okay, so we have 12. So we need to split 12 into 2. Okay, so what are the factors of 12? So there are a lot of factors of 12. We have 12 times 1, 6 times 2, and 4 times 3. Okay, so suppose I choose 4 times 3. Okay, so 4 times 3 is equal to 12. Okay, but 4 is still factorable because it is a composite number. So we need to split 4. So we have 2 times 2, and 3 is already a prime number. That's why we can put it down. Okay, next. So we have 20. So the factors of 20 are, we have 20 times 1, 10 times 2, and 4 times 5. So I chose 4 times 5. Okay, and the same here. 4 is still factorable by 2 times 2, and 5 is already a prime number. So we can put it here. Okay, after that, let's put this in column. Okay, so we have 12. The factors of 12 are 2 times 2 times 3. Okay, so as you notice, I use that as a multiplication. X and that are the same. Okay, then 20 is equal to, we have 2 times 2 times 5. Okay, then we're going to encircle the numbers that they have in common. So we have 2 here and another 2. So as you notice, we have 3 here, but we don't have here. And we have 5 here, but we don't have here. That's why 3 and 5 are not the common factors. The only common factors of 12 and 20 is 2 and 2. Then we'll write down 2 times 2. Then we are going to multiply, which is equal to 4. Therefore, the GCF of 12 and 20 is equal to 4. Okay? Let's give another example. Suppose we have 4x squared and 8x. First, we need to get the prime factors of each expression. The prime factors of 4x squared is equal to 2 times 2 times x times x. While the prime factors of 8x is equal to 2 times 2 times 2 times x. Okay? So let's encircle the common numbers or factors. So we have 2 and another 2. And we have x here. So those are the common. So we have 2 times 2 times x. Then we simply multiply. 2 times 2 is 4 times x is equal to 4x. Therefore, the GCF of 4x squared and 8x is equal to 4x. As we recall, factoring is the reverse method of multiplication. Am I right? 3 times x plus 2 is equal to, so by simply multiplying 3 by x, we have 3x plus 3 times 2 is 6. Okay? So, this is the product or the multiplication. And this is the factors. Let's study further. Suppose we have 10y squared, 15y cubed, and 25y to the 5th power. So we have 3 expressions. Now, observe carefully their numerical coefficient. What is common in 10, 15, and 25? Yes, they're all divisible by 5. Okay, so 5 is their common divisor. How about the variable y? We have y squared, y cubed, and y raised to the 5th power. So we have y squared here, then we have y cubed. You can have y squared also here, and also here. Therefore, their greatest common factor is 5y squared. Another example. We have 10y cubed minus 15y to the 5th power. Okay. Observe carefully the numerical coefficient of 10 and 15. What is the common divisor of 10 and 15? The common divisor is 5. And how about the variable? The common divisor also is y cubed. Okay. Then, we're going to use this as our divisor. 10 divided by 5 is 2. Y cubed divided by y cubed is 1. So we are going to cancel it out. Minus 15 divided by 5 is 3. Then we have y to the 5th power divided by y cubed, that is y squared. Okay, so therefore, the factors or greatest common factors of 10y cubed minus 15y to the 5th power is 5y cubed. Let's take another example. 7r raised to the 4th power plus 21r raised to the 6th power minus 28r raised to the 7th power. Now, observe carefully the numerical coefficient. So, we have 7, 21, and 28. So, what is their common divisor? Okay. Right. this 3 is divisible by 7. How about the variable r? So we have r raised to the 4th power, r raised to the 6th power, and r raised to the 7th power. Can we put here r raised to the 6th power? Let's check. Here we have r raised to the 7th power. Yes, we can use 6. How about here? R raised to the 6th power? Yes. But in here, we can't have r raised to the 6th power because 4 is smaller than 6. That's why we only have 4. There. Then, by simply dividing this by this, we have 7 divided by 7, that is 1. And r raised to the 4th power divided by r raised to the 4th power, that is simply 1. Plus 21 divided by 7 is 3. Then r raised to the 6th power divided by r raised to the 4th power, we simply subtract their exponent. So we have r 6 minus 4 is equal to 2. Then we have minus here, 28 divided by 7, we have 4. R raised to the 7th power divided by r raised to the 4th power, we have r cubed. So this is the factors of this expression.